In this section or module, we'll actually go through some of the key concepts related to basic networking concepts using Linux. As part of this beginner level Linux course, so far we have gone through quite a few details related to shell commands. However, if you have to support applications that are deployed on Linux, understanding networking concepts is very, very important. To make sure we get some basic networking concepts, first we'll actually provision EC2 instance from AWS. Once we get EC2 instance from AWS, we'll go to the details related to security group. It is very, very important for us to understand the relevance of security group. Otherwise, we will not be able to access the applications we are going to set up to understand basic networking concepts. Once we get knowledge related to security groups, then we'll actually talk about different types of IP addresses. Then we will install Apache Webserver on it. Once we install Apache Webserver, we'll understand how to update security groups so that we can access Apache Webserver. In that process, we'll also understand how to troubleshoot the networking issues. Then we'll actually understand what is a daemon or background process, and also we'll understand the concepts of ports. Then we'll actually go to the details related to structure of IP address. Once we understand the structure of IP address, we'll also understand something called as DNS aliases for IP addresses. DNS aliases are nothing but meaningful names for the IP addresses. It will be tough for us to remember IP addresses. However, it will be easier for us to remember DNS aliases. Gmail.com or Google.com is an example for DNS alias for the application that is set up to support Gmail or Google. Once we go to the details related to port numbers, IP addresses, DNS aliases, etc., we'll actually install Jupyter Lab on the same machine. Then we'll again go to the details about updating the security group so that we can access the Jupyter Lab environment without any issues. Once you install Jupyter Lab and start, it will be running on port number 8888. To access from the external world, you need to make sure the port is updated as part of the inbound rules in the security group. Also, we need to provide the required IP addresses to access this. You can also use Telnet to validate whether the application can be listened on port number 8888 or not using appropriate public DNS. Once we go to the details related to Jupyter Lab, which is an example for the application, we'll actually go to the details about setting up MongoDB. MongoDB is a database. It will be running on port number 27017. Unless and until we update 27017 as part of the security group inbound rules, the external world cannot access. We'll take care of it, and also we'll use Telnet to confirm whether we are able to talk to MongoDB that is running on port number 27017 or not. We'll be going through the details using Apache 2, which is a simple web application, Jupyter Lab, which is a real-time example for a web application, and also MongoDB database, which is a real-time example for a database, to understand the relevance of applications and associated ports. And also we'll go through the details related to security groups or firewalls, and also how to use tools such as Telnet to validate whether these are accessible or not. Once we go through this, you will definitely have fair understanding about all the basic concepts related to networking in Linux. It will facilitate you to support the applications that are deployed on Linux without much gaps. As part of this sectional module, we are going through the details related to basic networking concepts using Linux. To demonstrate, I will be provisioning EC2 instance from AWS with Ubuntu 20.4 operating system. In this case, I will be provisioning a bit higher end system than T2.micro, which means you have to pay for it. Depending upon the number of hours you use, you have to pay for it. You can go to the pricing calculator and you can enter the details to get the estimate. In this case, I'll be using T2.medium. Let me go to the pricing calculator. I can actually go to this link, calculator.aws.com. Once you are here, you can click on create estimate. It shouldn't take more than 4 to 8 hours to complete this complete section, and we'll be using a T2.medium instance to take care of this. We can actually search for EC2 here. Click on configure. We'll be using US East North Virginia. You can choose whatever you want, and you can select the appropriate region here to get the cost estimate. When it comes to the operating system, it is nothing but Linux. When it comes to the instance, I'll be searching by name. The instance which I wanted to use is nothing but T2.medium. So let me search for T2.medium. You can see that you will be getting 4 GB memory and 2 vCPUs. This is good enough to explore all the basic concepts related to networking. Now you can scroll down. Let's assume we'll be using this for 10 hours in a month. It shouldn't take more than 10 hours. So this is the worst case. I'm saying 10 hours per month. When it comes to the storage, let's assume we will be having 30 GB storage for this. You can see that for 10 hours, it is $23.95. I think it is not right. To get the right estimate, we need to choose on-demand instances. Now you can actually see the cost. It is only $3.46. The actual cost for the instance is only 46 cents. $3 is for the storage of 30 GB for the whole month, as we'll be terminating the instance along with the storage after 10 hours, even this cost will be significantly low. Within $1, you should be able to perform all the tasks that are going to be demonstrated in this sectional module using T2.medium instance. That being said, now you should be able to go here, click on launch a virtual machine, or you can also go to EC2 console and then click on launch virtual machine. Then it will take you to the wizard. We have already seen this in the past. Now let's say networking demo. This is the name of the instance. We'll be using Ubuntu. We'll be creating only one of them. The version is nothing but 20.04. Instance type is nothing but T2.medium. Key pair is nothing but GS demo. We can leave this as is. We don't need to update any network settings here. When it comes to storage, we can upgrade it to 30 GB. Let's say 30 here. Now let's scroll down. That's it. We don't need to make any changes. You can see the storage is 30 GB. The server type is nothing but T2.medium. The operating system version is nothing but Ubuntu 20.04. After reviewing these details, we should be able to click on launch instance. It will take care of creating the instance for us. As the instance is created using JSDemo key pair, we should be able to use jsdemo.pem to connect to this instance. We need to wait until the instance is in running state. We can click on the link related to the instance. We can wait until the state is changed to running. Then we should be able to connect to this instance without any issues using a JSDemo PEM file. Now the instance state is changed to running. We should be able to select this. We can pick the public IPv4 DNS. Now we should be able to open the terminal. We can say ssh-i ~downloads, then gsdemo.pem, then Ubuntu, it is the username. Then we can paste the public IPv4 DNS for this EC2 instance, and then we should be able to get into the EC2 instance without any issues. You can see that I am able to log in into the EC2 instance without any issues. We should be able to run lscpu command to get the CPU details. You can see that we have 2 vCPUs. Also, we can use free-h to get the details about the memory. You can see that the memory is 4 GB. As of now, the available memory is 3.5 GB. Also, you can get the storage details by running df-h command. You can actually see the details with respect to each and every mount point. In this case, we are interested in root mount point. You can see the size of the root mount point. It is nothing but 30 GB. As of now, 1.5 GB is being used and 28 GB is available. This is how you should be able to provision EC2 instance of type T2.medium to explore details related to networking concepts. We'll be going through all the networking concepts using this EC2 instance. As part of basic networking concepts using Linux, so far we have provisioned EC2 instance from AWS. Before going to the details related to basic networking concepts, let's understand AWS security groups. Security groups is similar to firewalls. If you are already familiar about firewalls in operating system, security groups is the logical abstraction of firewalls on AWS. Now you have the virtual machines such as JSDemo or JSDemo1 or JSDemo2 or even networking demo. Now the security groups will be added on top of this. It's a logical group. All the traffic will go through that security group, and based upon the rules, you will be able to access certain things in these virtual machines. If security groups block certain access, you will not be able to access. Let's understand how to get security group details from the EC2 instance, then we'll take it further. Now, already we are in the instance that is actually started in previous lecture. With respect to security groups, you can click on security after selecting the EC2 instance. Then you should be able to get the details about the security group. You can see the security group here. You can click on it to go into the security group. When it comes to security group, you will find inbound rules and outbound rules. Typically, we don't worry too much about outbound rules. Inbound rules is more critical. It actually limits the access of the services that are going to run as part of the virtual machines that are provisioned from AWS. For that purpose, we typically use inbound rules only. Now, I have already clicked on inbound rules here. I should be able to scroll up here. For some reason, it is not showing up. I think if I click on edit inbound rules, I should be able to review all the inbound rules. As of now, there is only one inbound rule. It is related to SSH. You can check the type here. It is SSH. When we choose SSH as a type, the protocol will be TCP. The default port with respect to SSH is 22. The source is nothing but anywhere. 0.0.0.0/0 means anywhere. From anywhere, we will be able to talk to this SSH service. Because we have this entry, we are able to connect to this EC2 instance. Otherwise, we will not be able to connect to this EC2 instance. Now, let me go to the terminal. Already, I am in the EC2 instance. I have used this command to connect to this EC2 instance. On top of the PEM file, I have specified the username and also public IPv4 DNS associated with this EC2 instance. Now, once I get into it, I should be able to run a command called as sudo service, then sshd status. You can see that sshd is running. Also, you can review the port. In this case, you can hit Ctrl+C to come out of this. Then you can say sudo view, then etc, then ssh, then sshd_config. This is the file which contains the entries related to SSH behavior. You can see the entry related to port. As of now, it is commented. If this is commented, it means it is using the default port, which is nothing but 22. As security group is being configured for port number 22 from anywhere, we are able to connect to this instance without any issues. Now let me go back to the terminal. Let me come out of this without saving. Now let me exit. I came out of the EC2 instance. Let me clear the screen. Now let me go back to the security groups page. Let's delete this entry. I have deleted the entry completely. Now let me click on Save Rules. Now the rule is updated. Let's go back to the terminal here. Now let's try connecting to the EC2 instance using this command. Now it will not work because the rule is deleted. You can also validate by using telnet. In this case, I'm saying telnet, and then I'm using this public IPv4 DNS. Let me paste. M is missing. Let me add M. Then say 22. You can see that telnet is struck. It is because the security group is updated by deleting the rule. As the rule is gone, we will not be able to connect to the instance. Now we have to add the rule back. Then only we will be able to connect to the instance. That being said, let me go back to this. Let me click on Edit Inbound Rules. Now we should be able to click on Add Rule. In this case, we have to choose SSH. When it comes to the source, we have to choose anywhere IPv4. Then we should be able to click on Save Rules. Now the rule is updated. Now we can come back here. As soon as the rule is updated, you can see that telnet is working as expected. We can come out of this by hitting Control and closing square bracket, and then by saying quit. Now we are out of it. Now we should be able to connect without any issues. You can see that it is connected to the EC2 instance without any gaps. This is about overview of AWS security groups. Whenever a particular application or service is running in the background on the server, there will be a port associated with it. Unless and until security group is updated with that port, we will not be able to access that. In the traditional systems, we call them as firewalls. Now, security groups is abstraction in AWS to cover the responsibilities of firewalls. It will make sure that unnecessary traffic doesn't come into the servers. As we add more services, we'll explore how to update security groups so that the services are accessible from the external world through the rest of the lectures in this section. That being said, as we got clarity around security groups, now let's spend some time in understanding different types of IP addresses that are associated with a server. At this time, we are going through the details about basic networking concepts using Linux. In this lecture, I'll actually talk about different types of IP addresses. I'm not talking about different IP addresses. I'm talking about different types of IP addresses. When it comes to the EC2 instances, you should be able to get the public as well as private IP addresses by looking at the instance details. You can click on the link. It will take you to that instance. You can select, and you should be able to see the private IP. You can see there is a private IP. It is nothing but this one. Also, there is a public IP. For a private IP, there is a private IP DNS. For public IP, there is public IP DNS. Now, these two are two different types of IP addresses. One is private IP, second one is public IP. You can also get the details about private IP on any machine using IP space ADDR command. Typically, there will be a network device that will be attached to the private IP. You can see here. This is the private IP. You can also confirm by looking at the EC2 console. Yeah, this virtual machine is provisioned from AWS. We should be able to get the details about private IP as well as public IP using AWS EC2 console. However, for other cases, you might not be having this type of UIs. However, you should be able to use IP space ADR command to get the details about the private IP. If public IP is also attached to the computer directly, you will also see the details about public IP. However, when it comes to EC2 instances, the public IPs will not be directly attached to the instances. There will be abstraction to it. We will not be having access to that abstraction directly. We can only get the public IP details using EC2 console. Otherwise, we have to run some complex commands to get the public IP details from the machine. That being said, this is the private IP. This is the public IP. So far, we have seen two types of IP addresses. On top of these two, we also have another type. It is nothing but localhost. Localhost spelling is nothing but this one. Again, localhost is nothing but alias to a special IP address. The special IP address is nothing but 127.0.0.1. It is also called as loopback IP. You can actually see here. LO means loopback, and you can see the IP address here. So on top of private IP and public IP, you will also have loopback IP or localhost. This is primarily used to talk to the same host within itself. For example, let's say you want to connect to the local machine using SSH. To see if we'll be able to talk to port number 22 using localhost, we should be able to say telnet localhost 22. You can see that it is working as expected. That means if we have private key, we should be able to connect to the same host using the same user without any gaps because SSH process is running. We'll also see few additional details as we go along in the course. We'll actually start a web server and we'll see whether we'll be able to talk to the local web server using telnet, and also we'll validate using curl. Then we'll actually take it further. Localhost is primarily used to talk to the services that are running on that machine locally without going through the public internet. That being said, there are three types of IP addresses. One is loopback, which is nothing but 127.0.0.1. It is also known as localhost. On top of it, we have private IP and public IP. There will be a device on the server which will be attached to at least one of the private IP. You can get the details by running IP space addr command. When it comes to the public IP, it need not be directly attached to the computer or machine which we have logged in. In those scenarios, you will not be seeing the details about public IP here. However, by using consoles like AWS EC2, we should be able to get the details related to public IPs as well. So there are three types of IP addresses: a loopback or localhost, private IP, and public IP. As part of this sectional module, we are going through the details related to basic networking concepts using Linux. So far, we have gone through the details about AWS security groups and also different types of IP addresses. Now, let's go ahead and install Apache Webserver. You will understand why we are installing Apache Webserver in the pursuit of understanding basic networking concepts by end of next few lectures. For now, let's go ahead and install Apache Webserver. We'll also see how to access it. In that process, we'll be even updating the security group. To install any software on Ubuntu-based operating system, one of the tools that can be used is nothing but apt. Using apt, we should be able to install. To run apt, we have to use superuser, or we should be able to use sudo if the user have access to sudo. In this case, Ubuntu have access to sudo, and hence we can say sudo apt install Apache 2. Apache 2 is the component which is supposed to be installed to have Apache Webserver on Ubuntu 20.04 based machine. Sometimes this might fail. If it fails, first we need to update, then we have to install. In this case, it is not failing. It is actually installing the Apache Webserver. Once it is installed, we will see whether it is automatically started or not. We'll also see how to manage it once it is completely installed. Now the installation is almost done. We just have to wait until it is completely done. Then we can actually take care of understanding how to manage this Apache Webserver that is being installed. Now it is successfully installed. You can validate by saying sudo, then service, then Apache 2, then status. You can see that it is running. You can also run lsf and ltr/etc. There should be a folder related to Apache 2. You can see the folder here. It is just set up, which means Apache 2 is actually installed on this machine. In case if you wanted to restart, you can use service Apache 2 restart to restart this service. Now Apache 2 is restarted. You can validate by checking the status again. You can also stop it by saying service, the service name which is nothing but Apache 2, then stop. It will take care of stopping the service. You can validate the status by running status command again. Now it is stopped. Now to start it, you can use Apache 2 start. It will take care of starting this service. Now Apache 2 service is up and running. You can also run command called as telnet localhost 80. As the service is up and running on port 80, we are able to listen to that without any issue. Now let's hit control and closing square bracket, then hit enter, then say quit to come out of this telnet. You can also use curl command by saying curl http://localhost. You can see the output here. It means we are able to access the application locally using curl. However, if we try to access the application from outside the EC2 instance, it will not work. In this case, to try accessing this web application that is running in this EC2 instance, we can use the public IPv4 DNS, which is nothing but this one. Then we can open another tab. Then we can say http:// paste and hit enter. you can see that the application is not accessible even though the web server is running on the EC2 instance. As security group is not updated to listen to port 80, it is not working. You can also validate by opening the terminal by exiting from this EC2 instance. You can say telnet, paste the public IPv4 DNS of the EC2 instance, then specify 80 as port. This is the port on which the application is running. You can hit enter. You can see that it is not able to listen to that port 80 because security group is not updated. As part of the next lecture, let's go ahead and update the security group and see whether we will be able to access this application via public IPv4 DNS, which is nothing but internally we are using public IPv4 IP itself. As part of this sectional module, we are going through details related to basic networking concepts in Linux. So far, we have provisioned EC2 instance and also we got an overview of security groups. Then we actually talk about different types of IP addresses. Then we have installed Apache Webserver. However, the Apache Webserver is not accessible from external systems such as our PC. So in this case, we are able to access the web application from the server itself, but when we try to access the web application from remote servers such as our PC, it is not working. One of the ways to address this issue is by updating the security group. To update the security group, we can actually go to the instance here, then click on security, then click on security group name here, then click on edit inbound rules. The reason why we are updating inbound rules is because we are trying to access the application that is running inside the server from the external application. The traffic is inbound in nature. We are getting the traffic from the external systems into the server and hence it is considered as inbound. Now, as part of this page where we can edit the inbound rules, as of now only port 22 is opened. You can add a rule. Then you can actually specify HTTP because we have set up Apache 2 web server. By default, it will actually start HTTP based web application on port 80 and hence choosing HTTP is good enough. Then as part of this, we have several options. We have custom, we have anywhere IPv4, anywhere IPv6 and also my IP. You can choose my IP. It means you will be able to access this web application only from this IP address. Even if I share the public DNS for the EC2 instance on which my application is running, you will not be able to access because I am restricting access to only my IP. Also, if my IP changes because of the nature of my internet provider, then I'll not be able to access even from this system. That being said, for now, I'll be using my IP. Let me click on save rules. Now, let me go to the terminal first. Let's run telnet command. We can listen to the application without any issue on port 80. You can see here, instead of saying unable to connect to remote host, it is actually able to show this output, which means it is able to listen to port 80 on the remote host. Now, as the telnet is working, let's copy this public DNS. I have copied this public DNS. Let me go to the new tab. Let me say http:// paste it, hit enter. You can see that the application is accessible without any issues. As soon as we have updated the inbound rules in security groups associated with the EC2 instance, the application is accessible. Both telnet as well as browser are working. This is how you should be able to open the port using a security group associated with the EC2 instance to access certain applications. As we have understood how to install Apache Web Server and also how to access it using public DNS from the external systems, now let's talk about overview of Daemon process and also ports. I'll be covering quite a few details as part of the next lecture related to Daemon process and ports. Then we'll actually see few more examples to understand how the ports are associated with the Daemon process and also how to access those Daemon process using appropriate ports along with the IP addresses. As part of this sectional module, we are going through the details related to basic networking concepts using Linux. In that process, we have provisioned EC2 instance and also we are able to access a couple of applications that are there on it. One is nothing but SSH, second one is nothing but Apache 2. As we have a couple of daemon process or background process and also as we are able to access those, now let's get an overview of daemon or background process that are running on the machine and also the associated ports with them. As of now, the two daemon processes that are running on the machine are nothing but SSHD and then Apache 2. When it comes to SSHD, it is running using port 22. When it comes to Apache 2, it is running using port 80. So 22 is the port with respect to SSHD. When it comes to Apache 2, the port is nothing but 80. Now these two are running on the machine. The daemon process are nothing but SSHD and Apache 2. The ports that are associated with them are nothing but 22 and 80. Like this, there might be additional applications as well. Going forward, we'll be setting up a couple of additional components. One is nothing but Jupyter Lab. I guess Jupyter Lab will be running on port 8888. Also, we'll be setting up a MongoDB database on this machine. The port on which MongoDB will be running is nothing but 27017. We'll be understanding how to access those from our PC by opening the ports in the security groups. For each and every daemon process that is running in the background, which is supposed to be accessed from the external systems, we need to have ports opened as part of the security groups. Then only we'll be able to access those from the external world. That being said, as of now, we have two daemon processes that are set up by us. One is there out of the box. It is nothing but SSHD. Another one is added by us, which is nothing but Apache 2. The way you can monitor is by using a command called as service. For that, first we need to log in into the system. Now I'm inside the system. Then using sudo, we should be able to validate by saying sudo service, then SSHD status. You can see that SSHD is running without any issue. Also, you can actually run sudo service Apache 2 status. Even this one is running without any issues. Going forward, we'll be setting up a few additional components on this. They are nothing but MongoDB and Jupyter Lab. Even there will be daemon process associated with them. We will see how to get the details of the daemon process, and also we will see how to access those from the external world. That being said, a daemon process is nothing but a background process that is running all the time behind the scenes. And also there is a port associated with the daemon process. Only using those ports, we will be able to access those services. Without the port associated with the services, we will not be able to access them. As part of this sectional module, we are going through the details related to basic networking concepts using Linux. So far, we have gone through the details about provisioning EC2 instance, AWS security groups, different types of IP addresses, setting up Apache Webserver on Ubuntu, and also making sure that we can access web application related to Apache Webserver. Also, we have gone through the details related to daemon or background process along with associated ports. Now, it is time for us to understanding structure of IP address. When it comes to IP addresses, they can be public, private, or localhost or loopback. Localhost or loopback means same. All these can be either IPv4 addresses or IPv6 addresses. In this case, we will be talking about IPv4 addresses only. Whether it is a public IPv4 address or a private IPv4 address or even a loopback or localhost IPv4 address, we typically have 4 sections. All the 4 sections are typically separated by dots. You can see here, this is the public IPv4 address, this is private IPv4 address. Also, you can actually connect it to the EC2 instance. Then you can actually say ping localhost. You should be able to see the details about the localhost IPv4 address, which is nothing but 127.0.0.1. Even this one is actually have 4 sections, and all the 4 sections are separated by dots. When it comes to these numbers that are separated by dots, this can go up to 255. It can't go beyond 255. So the maximum IP address which you can use is nothing but 255.255.255.255. Most of the public IPv4 addresses will be something like this. In this case, you have 52. Even if you ping Gmail, let's say ping www.gmail.com. This is nothing but a domain name or DNS alias. You can see the corresponding public IPv4 address for this domain. It is nothing but this one. These will change, however, the domain will remain same. There are quite a lot of concepts under the hood. You don't need to worry too much about those things. For now, you just need to remember that when it comes to any IPv4 address, it have 4 sections. All the 4 sections are separated by dots. Each section can go up to 255. Most of the private IPv4 addresses will be starting with 172 or 192 or similar numbers. Public IPv4 addresses can start with anything. That being said, as we have understood structure of IP address, now it is time for us to understand the concept of DNS aliases or domain names for IP addresses. As part of the section related to basic networking concepts using Linux, in the previous lecture, we have gone through the details about understanding structure of IP address. Now, let's understand details about DNS aliases or domain names for IP addresses. You pick any domain, whether it is gmail.com or bankofamerica.com or jpmorganchase.com or google.com. Everything will be associated with some IP address under the hood. But the IP addresses are hidden from us. We typically interact with remote applications via domain names or DNS aliases. Already we have pinged www.gmail.com. Even though this is readable domain or DNS alias, under the hood it is actually pointing to this IP address. Any server can typically be accessible only through IP address. However, it is tough for us to remember these IP addresses to access the applications. That's why we'll map domain to these IP addresses. Even if you say ping www.google.com, you should be able to see the IP address associated with google.com. It have 172 dot, however, this is public IPv4 address only. When you actually ping these domains from your servers, you might end up seeing a different IP address altogether. It is because for these domains, there will be multiple IP addresses under the hood from the perspective of load balancing. We'll not be getting into all those advanced details at this time. Just keep in mind that any domain or DNS alias will be mapped to IP addresses under the hood. You will be able to talk to the servers only using IP address. Also, when it comes to AWS, you need to keep few things in mind when it comes to IP addresses and corresponding DNSs. In this case, we have two IP addresses. One is private IP address. Second one is public IP address. For private IP address, we have DNS. You can see here, this is private IP DNS. For public IPv4 address, you can see the public IPv4 DNS. You can also observe that the private IP DNS is actually derived from private IPv4 address. When it comes to private IP DNS, it is nothing but IP-172-31-55-101.ec2.internal. If you remove this, and also if you remove this, then if you pick it up and replace hyphens with dots, it will be equivalent to this one. It means AWS follows a particular standard while creating private IP DNSs from IPv4 addresses. In the similar manner, if you look at public IPv4 DNS, if you remove this part, .compute, then .amazonaws.com, after compute it can be -1, -2, whatever it is. If you pick this and remove this, and also if you remove EC2 hyphen, then if you only consider this and replace hyphens with dots, this will be equivalent to this one. So public IPv4 DNS is actually derived from public IPv4 address. Also, if you get into the EC2 instance, you can run IP space ADDR. You should be able to see the private IP address here. This is private IP address. When it comes to the host names are actually derived from the private IP addresses. You can actually say hostname -f. It is nothing but private DNS, what we have seen here. The private IP DNS is nothing but this one. You can actually compare this with the hostname. The hostnames are actually configured based upon the private DNSs only. And private DNS is actually derived from private IP address. So there is a strong relationship between a private IP address and private DNS, as well as public IP address and public DNS in AWS EC2 instances. You need to remember this. That being said, as we have understood quite a lot of concepts related to IP addresses and DNS aliases associated with the AWS instances, now it is time for us to install additional softwares and also do necessary to actually access the applications that are added because of the softwares. We'll start with the Jupyter Lab, then we'll actually get into the details related to MongoDB. As part of the section module, we are going through the details related to basic networking concepts using Linux. To understand basic networking concepts, we have not only provisioned EC2 instance from AWS, we have also added software such as Apache 2 on it. We have even gone through the details about opening port 80 as part of the security groups so that the web application that is set up because of the Apache 2 is accessible. Now let's take care of installing Jupyter on this machine. We'll be installing something called as Jupyter Lab. We should be able to install Jupyter Lab using pip from Python. After setting up the Jupyter Lab, we'll be having not only SSHD as well as Apache 2, but also Jupyter Lab on this EC2 instance. Now let me go to the terminal. I am in the terminal. Now let's say pip install, then Jupyter Lab. By default, you will not be having pip on these machines. You can see that it is failing. It is saying command pip not found, but can be installed with sudo apt install python 3 -pip. Pip typically comes as part of Python 3. To confirm whether pip is already there as part of Python 3, you should be able to say python 3 -m pip. Then you should be able to specify the module which you wanted to install. In this case, it is nothing but Jupyter Lab. Let me hit enter. You can see that it is complaining saying no module named pip, which means there is no pip installed on this machine. So we should be able to use this command and we should be able to try installing pip. It might fail if the apt lists are not up to date. If this fail, we need to first update the apt list, then we have to run this command. Let's hit enter. You can see that it is complaining saying package python 3 -pip has no installation candidate. So in this case, we need to update apt lists. The way you can update apt lists is like this. You can say sudo apt update, hit enter. It will take care of updating the apt list for you. Now the apt list is being updated. Let's wait until apt list is completely updated. Now it is updated. Now we should be able to say sudo apt install python 3 -pip. It will take care of installing the pip for us. We just have to hit enter to continue. Now you can see that Python 3 -pip module is being installed. Once it is installed, we should be able to use Python 3 -m pip command to install any library or module. We'll be using that command to install Jupyter Lab. Once Jupyter Lab is installed, we should be able to start it. And also we can configure the security groups to access Jupyter Lab from the external world. In this case, external world means our PC or Mac from which we are trying to access that application. Now Python 3 -pip is installed. We should be able to run command called as Python 3 -m pip Jupyter Lab. Hit enter. It will take care of installing the Jupyter Lab for us. However, it is complaining saying unknown command Jupyter Lab because I have missed install init. So the actual command is nothing but Python 3 -m pip install then Jupyter Lab. Now Jupyter Lab will be installed as part of this machine under Python 3. Once it is installed, we should be able to access Jupyter Lab by using Jupyter Lab command. We will go through the details once the installation is complete. Now Jupyter Lab is successfully installed. Let me clear the screen. Now let me say Jupyter Lab. You can see that it is failing, saying command Jupyter not found. Probably I might have to relogin. Let me exit. Now let me log in once again onto this EC2 instance. Once I log in, let me attempt to run Jupyter Lab command. Let me say Jupyter then lab. Now you can see that it is complaining with a different error. We need to make sure that this is fixed. Let me go through the errors here. It is saying from markup safe, import markup, blah, blah, blah. Cannot import name soft code from markup safe. I don't know why it is complaining on this. We need to troubleshoot the issue. For now, let's say Jupyter Notebook to see if Jupyter Notebook can be launched or not. Even Jupyter Notebook is not working. So I need to troubleshoot this issue. It seems there are a few issues with respect to version compatibility. Let me try running this. Let me copy this. Let me go here and then let me say Python 3 -m. Let me paste it, hit enter. Now let me actually try running Jupyter Lab. Now the Jupyter Lab is started. So the command which I have used to fix the issue is nothing but pip install -user -upgrade AWS -sam -CLI. Because we are using EC2 instance, most likely it is causing this issue. There might be few things which are related to AWS that are installed on that EC2 instance. If you are using some other instance, you might not run into this issue. However, if you run into this issue because of whatever reason, you can try fixing it using this command. That being said, now Jupyter Lab is running. We can open another tab. Let me open a new tab by saying duplicate tab. Now let me go back to the EC2 management console. Let me pick the public IPv4 DNS. Let me connect to the EC2 instance by saying ssh-i /downloads, then gsdemo.pem, then Ubuntu @public IPv4 DNS. Now I am connected to the EC2 instance. Now I can say telnet localhost 8888, hit enter. The reason why I am using 8888 is because Jupyter Lab is started on that port. You can see here. You can also use curl command and run curl against this URL. It will work. You can see the output here. Let me come out of this. Now let me say curl, paste that URL, hit enter. You can see the details related to the page that will be rendered when we use that link. However, in this case, the link doesn't mean anything when we try to use it on our browser. As we have successfully set up Jupyter Lab and also as we are able to start it, now it is time for us to understand what is happening when we start. Also, we need to make sure that Jupyter Lab is accessible from the external world. When I say external world, I am talking about our PC or Mac from which we wanted to access this Jupyter Lab. Let's go to the details so that you understand what I am talking about here. As part of this external module, we are talking about basic networking concepts using Linux. So far, we have set up EC2 instance and also we have set up software such as Apache 2 as well as Jupyter Lab init. You can see the diagram for your reference. We have SSHD out of the box, then we have set up Apache 2 and also we have set up Jupyter Lab. Also, we have started Jupyter Lab. As Jupyter Lab is successfully set up, we are able to start without any issues. Now let's hit Ctrl+C and kill it. Now let us understand what all different options we have to start Jupyter Lab. For that, you should be able to say Jupyter Lab, then --help. You should be able to see all the options we have. The simplest command is nothing but Jupyter Lab. It will take care of starting the Jupyter Lab on localhost. we can try running Jupyter Lab command without any arguments by saying Jupyter space lab. You can see that Jupyter Lab is started on localhost with port number 8888. When Jupyter Lab is started on port number 8888 using localhost, you will not be able to access this from the external world. However, you will be able to access this from the EC2 instance itself. Let me duplicate this. Let me open a new tab by clicking on duplicate tab. Then let me connect to the EC2 instance by saying sh-i-/downloads, then gsdemo.pem. Then I have to give the username. The username is nothing but Ubuntu. The public IPv4 DNS is nothing but this one. I have copied public IPv4 DNS. Now let me say Ubuntu @public IPv4 DNS, which is nothing but this one. Let me hit enter. Now I am inside the EC2 instance. You should be able to access the application using two approaches. One is telnet. It will take care of listening to the application using the port and IP address. In this case, the IP address or DNS alias related to the IP address on which the application is running is nothing but localhost. The port is nothing but 8888. Now you can see that you are able to listen to port 8888 using localhost. It is because Jupyter Lab is started using this on this EC2 instance. You are trying to access the application from the EC2 instance itself. If you go back to this picture, in this case, the telnet is being run from the EC2 instance itself. That's why it is working. Now let me go here. Let me come out of this by saying control closing square bracket, hit enter, then quit. Now I'm outside the telnet. Now let me use the private IP or DNS associated with the private IP. We can get the details about private DNS by saying hostname -f on EC2 instance. This is the IPv4 DNS for private IP. I should be able to copy this, then say telnet, paste, port number is nothing but 8888. You can see that it is complaining saying unable to connect to remote host. Even though you are able to talk to this application using localhost and port number 8888, you are not able to talk to the application using private IP or DNS associated with the private IP and port 8888. Even with public DNS, you will not be able to access this application. Let's say telnet. Let's give the public DNS. The public DNS is nothing but this one. I have copied it. Let me go back to the terminal. Let me paste it here. Then say 8888. Hit enter. It is saying connection refused, which means even using public DNS or public IP and port 8888, we are not able to talk to this application that is running currently using localhost. Now let me hit Ctrl C. Let me say Y. Let me come out of this. Then let's explore different options that are there to start Jupyter Lab. To see all the options, you should be able to get the help by saying Jupyter Lab -help. You can see all the details here. You can customize the IP address by using -IP. You can actually specify the IP address here. Either you can use localhost, which is default, or you can configure private IP address, or you can also use universal IP address. The universal IP address is nothing but 0.0.0.0. When we use 0.0.0.0, the application will be bound to all the IP addresses associated with this machine. So in this case, to make sure we can access the application both via localhost as well as private IP and public IP or DNSs associated with the private IP and public IP, we have to use 0.0.0.0 with -IP, then it will work as expected. Now let me say Jupyter space lab, then -IP, then 0.0.0.0. You can also specify equal between IP and this one. Even space will work. Now let's hit enter. Now you can see that it is bound to the private IP as well as loopback IP or localhost IP. Now we can go here. Then we should be able to validate whether we'll be able to listen to that application via localhost or not by using this command. You can see that we are able to listen without any issues. Let me come out of it. Now let's go ahead and run telnet using private DNS. Even this one is working. Let me come out of it. Now let me try using public DNS. Even this one is working. You can see that even when we use public DNS, it is actually getting into the application using private IP only, which means from the external world, when we use public IP, it is actually mapped to the private IP associated with the server. However, still we will not be able to access the application. The reason why we will not be able to access the application is because as part of the security group, the port number is not opened. Now let me copy this. Let me go to the browser here. Let me open a new tab. Now let me say http:// then the public DNS :8888. That is the port on which Jupyter Lab is running. Now you can see that we are not able to access the Jupyter Lab environment, even though the Jupyter Lab is started by using 0.0.0.0 as part of IP. We need to make sure the port is opened as part of the security group. Then we'll be able to access the application without any issues. Let's go to the details about updating the security group to access Jupyter Lab as part of the next lecture. As part of this section module, we are going through the details related to basic networking concepts using Linux. In that process, so far we have set up Apache 2 as well as Jupyter Lab on top of SSHD. SSHD comes out of the box. Because of SSHD only, we are able to connect to the EC2 instance using SSH. Also, after installing Apache 2 to access the web application associated with Apache 2, we have opened port number 80 as part of the security group. As of now, we have even set up Jupyter Lab on the EC2 instance. However, it is not accessible even though it is being run using port number 8888. Let me update the port number here. It is nothing but 8888. However, we are not able to access this because security group is not updated yet. Let's go ahead and take care of updating the security group and see if we'll be able to access the Jupyter Lab without any issues. For that, we can go to the EC2 management console. We need to make sure appropriate EC2 instance is selected. This is the EC2 instance which is being used for the demonstrations. Once it is selected, you can go to the security. Then you should be able to click on security group associated with this EC2 instance. Now we have to edit inbound rules because we are trying to access Jupyter Lab from the external world. The traffic is inbound into the server and hence we have to edit inbound rules. Now we can say edit inbound rules. Now we should be able to say add rule. In this case, we have to use custom TCP only. The protocol is TCP. Port range is nothing but 8888. The source, let's say my IP. You can also use anywhere and you can actually configure with 0.0.0.0/0. In that case, anyone can access your Jupyter Lab environment. In this case, I have configured this rule using my IP, which means I'll be able to access Jupyter Lab environment running on EC2 instance only from this system where this IP address is mapped. From other systems, we will not be able to access Jupyter Lab. That being said, we need to make sure we save the rules by clicking on Save Rules. Once it is saved, we should be able to go here, refresh this. Now we should be able to access the application without any issues. You can also go to the terminal. You can come out of this session. And also you can exit from EC2 instance. Now you can say telnet, give the public DNS, which is nothing but this one. Then port 8888. You should be able to listen to Jupyter application that is running on this instance using port 8888. In this case, I am running telnet from the external PC, which is nothing but my Mac. Now you can see that you are able to access the application even using telnet from the PC onto that EC2 instance. This telnet is being run from our PC. If you relate it to this diagram, now telnet is being run from here. Also, our browser is here. We are able to access the application using public DNS along with port number 8888. You can see here. However, it is not logged in automatically because I haven't copied the token. Now to pick the token, I can go back to the terminal. Let me go to the terminal here. Then let me go to this session where Jupyter Lab is started. You can see the token here. We can copy this token, then go to the browser, paste the token here, click on login. Now it should be able to log in into the Jupyter Lab environment without any issues. This is how you can actually set up any application on the EC2 instance, and then you should be able to open the ports as part of the security groups. Once the ports are opened as part of the security groups, you should be able to access these applications from the external world. In this case, Jupyter Lab is set up using port 8888 with universal IP 0.0.0.0 as the Jupyter Lab is running using universal IP 0.0.0.0 on port 8888, and also as port 8888 is opened as part of the security groups from my PC, I'm able to access this without any issues. As part of this sectional module, we are going through the details related to basic networking concepts using Linux. So far, we have set up Apache 2 as well as Jupyter Lab on top of SSHD. SSHD comes out of the box, whereas Apache 2 and Jupyter Lab are not only installed, but also the ports associated with the applications related to these are actually opened as part of the security groups. Now, let's understand how to install databases like MongoDB on these EC2 instances, and also let's go through the details about how to access these databases from external world. When I say external world, I'm referring to the PCs or Macs associated with us. That being said, let's go ahead and install MongoDB on this machine, then we will take it further. Once again, you should be able to get into the EC2 instance. If your Jupyter Lab session is still active, you can hit Ctrl+C and then say Y to kill the session. Then you should be able to say apt install. You have to pass appropriate value with respect to MongoDB. For that purpose, we can actually go to the browser, then open a new tab, go to the google.com, search for install MongoDB Ubuntu 20.04. Now we should be able to click on this, how to install MongoDB on Ubuntu 20.04. This link is from DigitalOcean. It is a reliable link. Now you should be able to scroll down. Then you should be able to copy this, go to the terminal, paste it. Once that is done, you can actually run this command apt key list. You can see the keys here. Now you should be able to copy this, then paste here. Then you can actually scroll down, then run this to update the apt lists. You can see that the apt lists are being updated with the MongoDB related stuff. Once it is done, then you should be able to copy paste this, which will take care of installing the MongoDB on this EC2 instance with the Ubuntu 20.04 operating system. Now you can see that MongoDB org is being installed. I have just hit enter to confirm. Now it is actually installing the MongoDB database. Once it is installed, we should be able to start the service using this command. Either you can use systemctl or service command. Let's try copying this. If it doesn't work, then we'll actually switch over to service command. Let's go back to the terminal. It is installed. Now we should be able to copy this, paste here. Now the MongoDB service is started. You should be able to validate the status by copy pasting this command. You can see that the MongoDB database server is running without any issues. There is a configuration file associated with the MongoDB that is installed. You can review the details by opening this configuration file. We can say cat then /etc/mongod-conf, hit enter. You can actually see that the port on which MongoDB is running is nothing but 27017. The IP to which it is bound is nothing but the localhost IP, which is nothing but 127.0.0.1. For that reason, when we say telnet, then localhost, then 27017, we should be able to listen to that port without any issues. However, if we use public DNS or private DNS, it will not work. Let me first use the private DNS. We should be able to get the private DNS on EC2 instance by running this command. This is nothing but private DNS. Let's copy this. Now let's say telnet, paste it, and then 27017, hit enter. You can see that it is complaining saying connection refused. Now let's also try telnet using public DNS. The public DNS associated with this EC2 instance is nothing but this one. Let me go to the EC2 console here. Let me say reload. It will take care of going back to the EC2 instance. In this case, it is actually going to the wizard. Let me click on instances here. The instance which we are interested in is nothing but this one, networking demo. Now we should be able to get the public DNS by clicking on this. Let's go to the terminal. Let's say telnet, then paste the public DNS, then say 27017. You can see that it is complaining, which means as of now, the database is accessible only from the EC2 instance. If we try to relate to this picture, now we also have MongoDB running on port number 27017 on this EC2 instance. However, using localhost, we should be able to connect to this MongoDB database, but from the outside world, we will not be able to connect to it. Also, from within EC2 instance, we will not be able to connect to it using either private DNS or public DNS. Let's try connecting to MongoDB CLI by saying Mongo, hit enter. You can see that you are connected without any issues. As we are trying to connect from the EC2 instance itself, you can see that it is trying to connect using this information. Now let's understand how to make sure the MongoDB runs on all the IPs associated with the EC2 instance. Also, we need to make sure the ports are opened as part of the security group so that from the external world, such as our PC or Mac, we will be able to connect to this MongoDB database that is running on the EC2 instance. At this time, we are going through the details related to basic networking concepts using Linux. After setting up Apache 2 as well as Jupyter Lab, now we are in the process of setting up MongoDB and also accessing it from the external world. Already MongoDB is set up on the EC2 instance. It is covered as part of the previous lecture. We can also see that we are able to access MongoDB from the EC2 instance itself. Once I log in into the EC2 instance, I can say Mongo. It is actually using this information to connect to the Mongo instance. Now let me come out of this. Let me say Mongo --help to get the usage of Mongo. If you have Mongo client installed on specific machine, you should be able to specify the host name by using --host. In this case, even though we are in the same instance on which Mongo is set up, we should be able to specify the private DNS or public DNS associated with this EC2 instance using --host. If everything is working as expected, we should be able to launch Mongo without any issues. Let me say hostname -f so that I can get the private DNS. This is the private DNS. Now I can say Mongo --host. Let's start with localhost. It should work without any issues. You can see that it is connected using localhost. However, if I exit from here, then if I say Mongo --host, then specify the private DNS. Let me paste the private DNS here. Now the private DNS is pasted. You can see that it tried to connect using this information. However, it is failing because as of now, MongoDB server is actually running using localhost only. To fix this, we need to update the configuration file. You can choose the editor of your choice. I'll be using VI editor. In this case, I can say sudo vi/etc/mongodb.conf. Now you have to go to the line where you have bind IP. As part of the bind IP, you can actually change it to 0.0.0.0. If you're not comfortable using editors, you can also say sudo, then scd-i, then s/127.0.0.1. You can actually specify 0.0.0.0, then /g. Then you should be able to specify the file name, which is nothing but etc/mongodb.conf. Now the file should have been updated. You can validate by saying cat/etc/mongodb.conf. Now you can review the value for bind IP. It is nothing but universal IP 0.0.0.0. Now we should be able to access MongoDB either by using localhost or private DNS. Let's start with localhost by saying Mongo --host localhost. You can see that it is working as expected. Now let's get the private DNS for this EC2 instance. It is nothing but this one. Now let me say Mongo --host, then let me copy paste this private DNS. However, it will fail. Even though we have updated the configuration file, we haven't bounced the MongoDB server. We need to make sure MongoDB server is bounced after making the change. To bounce, we should be able to use sudo systemctl command. We can actually specify the Mongo or MongoDB. Let's go through the earlier commands which we have used. For that, I can actually say history pipe grep, then systemctl. The command which we can use is nothing but sudo systemctl restart mongod or mongod.service. Either of them will work. Now let's try connecting to the MongoDB using this command. You can see that it is working as expected. You can also come out of this, then say telnet, then copy this private DNS, then say 27017. You can see that we are able to talk to MongoDB server running on port number 27017 via private IP. You can also come out of this, then get the public IP or public DNS related to this EC2 instance, which is nothing but this one. Let me copy this. Now let me say telnet. Let me paste it. Then let me say 27017. You can see that it is working as expected. We can come out of it. You can also say Mongo --host, specify the public DNS. You can see that it is working as expected. However, if we come out of this session, I'm already out of this session. Now if I say telnet, then public DNS, then say 27017, you see it is stuck. Even though MongoDB is running using universal IP 0.0.0.0, I'm not able to connect from the external source because the security group is not updated. It is important for us to update the security group. In AWS environment, we have to update security group. In other environments, it might be called as firewalls. So either you have to deal with security groups or firewalls to open the port 27017 so that the external world can connect to the MongoDB that is running as part of this EC2 instance. I'll be covering those details as part of the next lecture. At this time, we are going through the details related to basic networking concepts using Linux. So far, we have set up multiple softwares on top of this EC2 instance. They are nothing but Apache 2, Jupyter Lab, as well as MongoDB. On top of these things, we also have SSHD out of the box. On top of setting up these softwares, we have also made sure that the applications associated with these softwares are running and also ports are opened so that we can access those applications. As of now, with respect to MongoDB, the port is not open and hence will not be able to talk to the MongoDB database from external world. Let's understand how to update security group so that we can access MongoDB database from the external world. We just have to go to EC2 management console. We need to make sure we go to the appropriate security group. For that, we have to choose the appropriate EC2 instance. In this case, the appropriate EC2 instance is nothing but this one. Once the appropriate EC2 instance is selected, you can click on security. Then you should be able to click on this one to go to the security group. Now you are in the security group. Already you can see that ports 22, 80 and 8888 are opened. Now we have to open another port. The port is nothing but 27017. In this case also, we are actually getting the traffic inbound to EC2 instance because we are trying to connect to MongoDB database from the external world, and MongoDB database is running as part of this EC2 instance. It is also categorized under inbound traffic, and hence we have to update inbound rule. First, we have to click on add rule here. Then we can specify custom TCP. In this, we have to say 27017. When it comes to the source, you can choose my IP. Only from my system with this IP, I'll be able to connect to MongoDB database. If the IP changes, we have to update the rule as well. That being said, we should be able to click on save rules. It will take care of updating the rule. Now we can actually go to the terminal, then run telnet with public DNS along with port number 27017. You can see that I'm able to talk to the database that is running as part of the EC2 instance with this public DNS on this port 27017. Now, to make sure we can connect to the MongoDB database, we need to have Mongo client. Only then we'll be able to connect to MongoDB database. Let me check if I have Mongo client or not on this machine. There's no Mongo client, and hence I will not be able to connect to the MongoDB database directly. First, I need to make sure I install Mongo client, then only I'll be able to connect to the MongoDB that is running on the remote machine. To install the Mongo client, let me search as part of Homebrew because I'm actually using Mac. For that, I can actually say brew search Mongo. Let me hit enter. Let me see if there is a client software. There is Mongo CLI, there is Mongoose, there is Mongoose. There are many other things. Let me try using Mongo CLI. I'm not 100% sure whether it will work or not, but I'll try to install Mongo CLI. Then I will see if I'll be able to access MongoDB that is running on top of EC2 instance using this Mongo CLI. Now Mongo CLI is being installed on this Mac. If you are using Windows, you need to make sure Mongo client is installed to confirm that you can actually talk to the MongoDB that is running on EC2 instance. Even when it comes to Ubuntu, you need to figure out how to install Mongo client to validate this. However, it is not important for you to validate whether you can talk to the MongoDB database using Mongo client or not at this time, as long as you understand the relevance of running the components on servers using universal IP, and as long as we are able to listen to the components via telnet from the external world, we are good to go. We don't have to validate using command line utilities or clients to actually confirm whether it is working or not. Telnet is more than enough. Let's wait until Mongo CLI is installed, then we'll take it further. Now the Mongo CLI is installed. We should be able to validate by saying Mongo and hitting enter. You can see that it is complaining Mongo command not found. Let me say Mongo and let me see if Mongo CLI can be accessible. Still it is not accessible. Let me try installing once again. It is saying it is already installed, but it is not working as expected. Don't worry too much about this. You just validate using telnet. As long as you are able to use telnet, you are good to go. If you are good at Python programming, you should be able to use PyMongo and you should be able to validate without any issues. But in this case, telnet is working and hence we are good to go. We are able to talk to MongoDB database that is running as part of EC2 instance. As we have covered quite a lot of details with respect to understanding basic networking concepts using multiple softwares of different categories, now it is time for us to wrap up by cleaning up the EC2 instance that is provisioned to explore these things. I'll be taking care of terminating this instance as part of the next lecture. As part of this sectional module, we have gone through details related to basic networking concepts using Linux. We have set up EC2 instance, and then we have installed quite a few softwares on top of it. SSHD comes out of the box. We have installed additional software such as Apache 2, Jupyter Lab, and also MongoDB. We have also gone through concepts such as different types of IP addresses. We have understood the structure of IP addresses. We have also gone through the details about DNS aliases for the IP addresses. Also, we have gone through the concepts such as Daemon process or background process along with port numbers associated with them. For each and every software we have seen here, there is a daemon process associated with it. We have seen how to make sure that daemon process is started using universal IP, which is nothing but 0.0.0.0, so that the applications are accessible from the external world. As we have gone through all the details related to basic networking concepts using Linux, now it is time for us to terminate the EC2 instance. For that, we can actually go to EC2 management console. Let's go to the instances. In this case, we'll also make sure that volume is deleted. You can actually go to the storage to get the volume name. The volume name is nothing but this one. It ends with D94. The size is nothing but 30 GB, and currently it is attached to this EC2 instance. Now we should be able to select this, and then we can go to instance state. Then we should be able to click on terminate instance so that the instance is terminated. Once the instance is terminated, we should be able to go to the volumes to confirm whether the volume ending with D94 is still there or not. Let me go to volumes here. Let me go through all the volumes here. We can actually search for D94. You can see the one with D94 here. It is still in use because the EC2 instance is being terminated. Let's go to the EC2 instance dashboard and see whether EC2 instance is already terminated or not. In this case, we are talking about this one. It is currently being shut down. Let's refresh until it says terminated. Now it is terminated. We can actually go to the volumes. We should be able to refresh here. Let's see if the one with D92 is still here. To simplify the search process for the volume that is associated with the terminated instance, I have sorted the volumes by size. As part of this list, only there are two volumes with 30 GB in size. These two volumes are associated with these two instances, which means the volume associated with the terminated instance is gone. This is how you should be able to clean up the instance and also volume. If you terminate the instance, automatically the volume will be deleted. In some cases, it might not. You can review and you can actually delete manually. That being said, I hope you have understood all the key concepts with respect to networking. Make sure you are comfortable with these basic networking concepts. They will help you in troubleshooting complex issues while you work as part of the projects in real-time environment. You need to practice enough to get hold of these key networking concepts.